Hi, I'm Joe James. In this video, we're going to cover exponents. We'll learn 9 different laws of exponents. I'll walk through a bunch of different examples so you can see how those laws apply. And then at the end, we'll walk through some sample problems so that we can use those laws of exponents to actually solve problems. What is an exponent? In this equation, m to the third power equals m times m times m. You can see the 3 here is an exponent. It's a superscripted 3, which means it's raised slightly higher, and it's smaller font. So m to the 3 power means that we're going to multiply m times itself 3 times. M times m times m. This is called a power or an exponent. In this equation, the exponent is 4. So p to the 4th power. Since we have an exponent of 4, that means we're going to multiply p times itself 4 times. So p to the 4th power is equal to p times p times p times p. That is not the same thing as 4 times p. It's p times p times p times p. So there are 9 different laws of exponents that we're going to walk through here. We're going to cover these in detail, and I'll show you some examples of each one so you can see how they apply and you'll understand it better. Some of these laws have a name. So the first one is the zero rule. The third one is the negative exponent rule. The number 5 is the product rule. 6 is the quotient rule. And number 8 is the power rule. So number 1, x to the 0 power is equal to 1. And in this case, x can be anything. We can take blob to the 0 power, and that's also equal to 1. We can take this big expression here, this hairy looking mess, and raise it to the 0 power by putting it inside of parentheses and raising it to the 0 power, and that is equal to 1. So we can even have my dog is lazy raised to the 0 power, and that is equal to 1. So I don't care what you have, anything you raise to the 0 power is always going to be equal to 1 if it's inside parentheses. So that's rule number 1. Anything raised to the 0 power is 1. Rule number 2 is almost as simple. Anything raised to the 1 power is itself. So x to the 1 power is x. Blob to the 1 power is blob. And this ugly expression, raised to the 1 power, 9 minus 8 is equal to 1. This big hairy expression is equal to itself. So anything raised to the power of 1 is itself. In other words, and it's implicit, there's an implied 1 there when you see an x. Rule number 3. X to the negative 2 power is equal to 1 over x to the 2 power. So what this tells us is that we can convert between a fraction and a non-fraction with a negative exponent. So x to the negative 3 is equal to 1 over x to the 3 power. You see we change the sign of the exponent when we move that term below the fraction to the denominator. And then in the second example, 1 over x to the negative 5th is equal to x to the 5th. So again, we change the sign of the exponent when we move the x to the 5th term to the numerator of the fraction. And we're doing the same thing here. 5x is inside parentheses to the negative 2 power. So we can move 5x to the 2 power to the denominator of the fraction and change the sign to a positive 2. And in this last example, 5x to the negative 2, there are no parentheses around the 5. So in this case, the exponent, negative 2, only applies to the x. So when we take away the negative sign, only the x squared moves to the denominator of the fraction. So we get 5, which remains on top of the fraction, 5 in the numerator divided by x squared. Rule number 4 says that x to the 1/2 power is equal to the square root of x. And you can also go the other direction. The square root of x is equal to x to the 1/2 power. In the second example here, z to the 3/2 power is equal to the square root of z cubed. This is the same as z to the 3 power times z to the 1/2 power, as you'll see in one of the other rules. In this case, we can substitute z to the power 3 for x. So z to the power 3 raised to the 1/2 power is the same as z to the power 3 square root. Rule number 5 is the product rule. It says that if you have the same base, you can add the exponents. So here we have x to the a times x to the b. that's equal to x to the a plus b. So when we're multiplying the same base, we can add the exponents. In example number 1, 18 to the 2 power times 18 to the negative 2 power, we add those exponents because we have the same base. We get 18 to the 0 power, and then we could apply the 0 power rule to get 1. In the second example, p squared r, we know from one of the previous rules that this r is actually the same as r to the power 1. So, again, ones that have the same base, we can add the exponents. So p to the 2 power and p to the 4 power becomes p to the 2 plus 4 power, or p to the 6. And then we add the exponents for the r's. R to the 1 times r to the 3 is equal to r to the 4. So we add the p exponents and we add the r exponents. This example is a little more complicated because we have to apply the distributive property. 5s to the 6th power, we have to distribute that across the first term and the second term inside the parentheses. So when we apply 5s to the 6th term, we're going to multiply the constants. 5 times 3 is 15. And s to the 6th times s to the 1, we add those two exponents and we get s to the 7th power. And when we multiply the second term, 5s to the 6th times 7s to the 2, we multiply the constants. 5 times 7 is 35. And then we raised s to the 6 plus 2 power, which gives us s to the 8th power. When we're multiplying constants and exponents, we multiply the constants and we add the exponents. Rule number 6 is the quotient rule, because we're dividing. So when we have the same base, x to the a divided by x to the b, we simply subtract the exponents. When you're multiplying two of the same base, you add the exponents. When you're dividing by the same base, you subtract the exponents. Here we have t squared divided by t to the 5th. We subtract 2 minus 5, and we get t to the negative 3. Then we could apply the negative exponent rule if we wanted to. That's equal to 1 over t to the 3 power. The next example, 8u to the 3 power divided by 4u squared. Well, 8 divided by 4, we divide the constants, is equal to 2. So 8 divided by 4 simplifies to just 2, and then u to the 3 over u to the 2, we subtract those exponents and we get u to the 1, or just u. In this example, we have v squared over v to the 4th, so we're going to subtract those exponents and get v to the negative 2, or we could also express that as 1 over v squared, using the negative exponent rule. In rule number 7, it's basically like a distributive property of multiplication. So xy raised to the a power, we have to apply the exponent to each of the variables or constants inside of the parentheses. In this case, we just have an x and a y, and they're both variables. We'll apply the a to both of those. You can see in the first example, we have a constant and a variable. We're going to apply the squared exponent to each of those. So we square the 7, and then we square the w. And we get 49, which is 7 squared, times w squared. In the second example, we have a negative 2 as our constant. So we have to apply the power 3 to the negative 2. Well, we get negative 2 to the 3rd power is negative 8. So we get negative 8, and then we have to apply the 3rd power to the a and the 3rd power to the b. So we get negative 8 times a to the 3rd power, b to the 3rd power. In rule number 8, we're taking x to the a power raised to some other power called b. This is called the exponent rule. And when we have x to the a raised to the b power, we multiply those two exponents. So here we have 3c squared raised to the negative 2 power. Again, we're going to distribute that negative 2 across each of the 3 and the c squared. So let's see, 3 to the negative 2 power is 1/9. And then we have to apply the negative 2 to the c squared. And when we do that, we multiply the exponents, and we get c to the negative 4, or 1 over c to the 4. So this becomes 1 over 9c to the 4. In the second example, we have a 2, a d cubed, and an e to the 4th. And we're raising all of that to the second power. So we're basically going to apply this square to the 2, which gives us 4, and then to the d cubed, we're multiplying those exponents. The 2 times the 3 gives us d to the 6th. And then e to the 8th power, because 4 times 2 is 8. So in raising a variable to another power, we multiply the exponents. And in the third example, we have 5f to the 4th. So we're going to take 5 to the 3rd power, and then we're going to take f to the 4th raised to the 3rd power. 5 to the f power is 5 times 5 times 5. That multiplies out to 125. And f to the 4th raised to the 3rd power, well, we multiply those exponents and we get f to the 12th. So that's rule number 8. Rule number 9 is similar to rule number 7. Rule number 7 is for multiplication. Rule number 9 is for division. So if we have x over y in parentheses raised to some exponent, we're going to apply the exponent to both the numerator and the denominator. So in the first example, we have 2 over g raised to the 3rd power. We are going to apply the 3rd power to the 2. So 2 to the 3rd power is 8. 2 times 2 times 2 is 8. And g to the 3rd power becomes g cubed on the bottom. So 8 over g cubed. In other words, we really just applied this 3rd power to the numerator and the denominator. In the second example, we have an h cubed on top. And when we square that, well, we multiply those exponents. We multiply the exponents, becomes h to the 6th power. The denominator, well, 5 raised to the 2 power becomes 25. And I squared raised to the 2 power becomes I4 because we multiply those exponents. So those are our 9 laws of exponents. We'll walk through some sample problems just so you can see how to apply those to solve some problems. In the first example, we have h to the 3rd times h to the 4th power. And we're multiplying, we simply add the exponents. So this becomes h to the 7th power. In the second example, we have j squared times k to the 3rd times j squared times k to the 3rd. Now, for the same base, we're going to just add those exponents. So here we're going to get j to the 2 plus 2 power, which is going to give us j to the 4th. And then the k is going to be k to the 3 plus 3, or k to the 6th power. In the next example, we have 5m to the 4th power times 3m to the 6th. So look, we want to multiply those constants. That's going to give us 15. 3 times 5 is 15. And then what do we want to do with the m's? Well, we're not raising any m to the power to some other exponent, are we? We're simply multiplying 2 terms together. And in that case, all we do is add the exponents. So we have an m to the 4th and an m to the 6th. That's going to give us, so m to the 10th. And in the next example, we have 12 n to the 6th over 4 n to the 3rd. Well, first, what is 12 divided by 4? We can take care of those constants. All we have to do is divide the constants. 12 divided by 4 is 3, right? And then the n term, well, we have n to the 6th divided by n to the 3rd. What do we do with those exponents in this case? Well, we subtract the exponents in a fraction, don't we? So that becomes n to the 6 minus 3, or n to the 3rd power. So this is n to the 3. So there's our first 4 examples. We've got a few more examples we'll walk through. So 3p to the 5th raised to the 2 power. We first have to apply this exponent rule. We're going to apply this squared to the 3, and then we're going to apply it to the p to the 5th. So we have to apply this 2 to each of these. The constant 3 squared becomes 9, right? So 3 squared is 9. And then p to the 5th raised to the 2 power, well, we multiply those together. So that becomes p to the 2 times 5th, or 10 power. So p to the 10, right? So p to the 10. All right. How about here? Well, let's see. We have 3 times 1/3. 3 times 1/3 is the same as 3 over 3, which is 1. So basically the 3 and the 1/3 cancel each other out. And then the r squared times r cubed. Oh wait, it looks like the r cubed is on the bottom. It's on the denominator of the fraction. So we really have r squared over r cubed. So let's see, 2 minus 3 is r to the negative 1. So that's going to give us r to the negative 1 power, which is the same as 1 over r. So this one gives us 1 over r. The constant goes away, and the 2 minus 3 becomes r to the negative 1, or 1 over r. And this one's just a simple product. So s to the negative 4 times s to the 3 times s to the negative 1. We just add all those up. Let's see, what do we get? Negative 4 and negative 1 is negative 5. And a positive 3 gives us a negative 2. So s to the negative 2. S to the negative 2 power. And that's the same thing as what? The negative exponent rule tells us that this is the same as what? 1 over s squared, right? So it's the same as 1 over s squared. You could express it either way. And then this last example, 4t squared times 3t cubed divided by 2t. Well, first let's take care of the constants. 4 times 3 is 12, divided by 2 is 6. So those 3 constants just multiply out to 6, right? We have a multiply and then a divide by 2. Okay, now let's look at the exponents. We're going to add the exponents that are on the numerator, and then we're going to subtract the exponent that's on the denominator. So this is implicitly, this is a 1, right? This is a 1 exponent here. So we have 2 plus 3, which is 5, minus 1 is 4. So that gives us t to the 4th power. T to the 4th power. So 2 plus 3 is 5, minus 1 is 4. So 6t to the 4th is what we get for that problem. That wraps up this video on laws of exponents. I hope this video was helpful for you. If so, please click like and subscribe to my channel. I'm Joe James. Thanks for watching.